Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology. Subject code OEC 754 Medical Electronics Unit 1. Topic Biopotentials, Biopotential Electrode, Biological Amplifiers. Objective to understand the different types of electrodes and its placement for various recording. First, we are going to see the biopotentials resting and action potentials. Resting potential. The membrane potential caused by different concentration of ions is called as resting potential. Cell in resting state is said to be polarized. That means it should be excited by the flow of ionic current. The movement of sodium ions constitutes an ionic current flow that further reduces the barrier. Action potential. The positive potential of the cell membrane during excitation is called as the action potential. A cell that has been excited and that displayed on action potential difference is said to be depolarized. That means it is the process of changing from resting state to the action potential is called as depolarization. Then next one is resting and action potential. The waveform shows the typical cell potential. That means it shows the net height of action potential as the difference between the potential of depolarized membrane at the peak of action potential and resting potential. Biopotential electrodes. Electrodes are employed to pick up the electrical signals of the body. Biopotential electrodes consists of different types: limb electrodes, floating electrodes, microelectrodes, needle electrodes, surface electrode. First, we are going to see the limb electrodes. It is made up of 4 leads placed on the extremities, that is left and right wrist, left and right ankle. It is made up of German silver, alloy of zinc, copper and nickel. The electrodes are held in position by elastic straps, so it is called as a limb electrodes. The size of the limb electrodes is usually 3 into 5 cm. Next one is floating electrodes. To overcome the problem present in limb electrodes, floating electrodes were used. Here, the interface can be stabilized by the use of floating electrodes, in which the metal electrode does not make direct contact with the skin. That means it consists of a lightweight metal screen held away from the subject by a flat washer which is connected to the skin. Next electrode is microelectrodes. It is used to measure bioelectrical potential near or within a single cell. It consists of 2 types, metal electrodes and micropipette. Metal electrodes are formed by electrolytically etching the tip of a fine tungsten or stainless steel wire to the desired size. Here the wire is coated with an insulating material. Next one is micropipette electrode. It is a glass micropipette with the tip drawn out to the desired size. It is also filled with an electrolyte compatible with the cellular fluids. In this micropipette electrode, you have dual interface. One interface consists of a metal wire that is in contact with the electrolyte solution inside the micropipette, and the another one is electrolyte inside the pipette and the fluid inside or outside the wall. Next one is needle electrode. Needle electrodes are used to record the peripheral nerve action potential. It is also used for EMG, consists merely of fine insulator wire. Their tips are in contact with the nerve, muscle or other tissue from the measurement is made. Here also you have 2 types of electrodes, unipolar needle electrode. Here the unipolar needle electrode consists of a single wire inside the needle, serves as a unipolar electrode. Next one is bipolar needle electrode. It consists of 2 wires are placed inside the cell, then the measurement is called as bipolar, and also it provides a very localized measurement between 2 wire tips. Surface electrodes. Electrodes used to obtain bioelectric potentials from the surface of the body are found in many sizes and forms. Surface electrodes are classified in the following types based on the construction. Immersion electrodes. It is used for the potential measurements and also simply buckets of saline solution in which the subject placed his hand and feet. Next one is plate electrode. It is separated from the subject skin by cotton or felt pad soaked in a strong saline solution. The last one is a floating electrode. The only conductive path between metal and the skin is the electrolyte paste or jelly. It forms an electrolyte to a bridge. Next one is biological amplifiers. Amplifiers are used to increase or boost the strength of the signals. Amplifiers is an electronic device that amplifies a weak signal. That means the output of this amplifiers is displayed as EEG or ECG waveform according to the biosignal input. So it is called as a bioamplifier. First one is preamplifier. It is an electronic amplifier that prepares a small electrical signal for further amplification or processing. It is also often placed close to the sensor, then only it can able to reduce the effects of noise and interference. It also used to boost the signal strength to drive the cable to the main instrument without significantly regarding the SNR. Here you are using one formula, that is a Frisk formula. That means when the gain of the preamplifier is high means then the SNR of the final signal is determined by the SNR of the input signal. Next one is differential amplifier. The potential difference between two electrodes on the patient could be measured with less electrical interference that can be done with a grounded system. Here, electronic amplifiers are normally referenced to ground through their power supplies. Here we have one technique. It will not only in electrocardiography but also in the measurement of other bioelectrical signals. It is the use of differential amplifier. In this differential amplifiers, it can be considered as two amplifiers with separate inputs and also you have a common output terminal. Next one is chopper amplifier. It is an excellent device for signal of narrow bandwidth and reduces the drift problem. It consists of two types, mechanical chopper amplifier and non-mechanical chopper amplifier. First one is mechanical chopper amplifier. It consists of diode, amplifier and relay. That means here S1 represents the electromagnetically operated switch. For example, when S1 is closed means what happened? Amplifier input term is connected with Q, then it is short circuited and the input voltage is 0. Suppose S1 is open. The amplifier receives an AC voltage varying from 0 to the value of the input voltage. Non-mechanical chopper amplifier. It consists of photodiode. It is also used for modulation and demodulation process. For example, when there is no light on photoconductor, what will happen? The resistance is very high and there is no current flow through it before it is in a reverse bias. It is also act as a switch on or off by means of incident light. Last one is isolation amplifier. It is also commonly used for providing protection against leakage currents in biomedical recorders such as ECG machine. It consists of three types: transformer isolation, optical isolation, capacitive isolation. Transformer isolation. It uses either a frequency modulator or a pulse with modulator carrier signal with small signal bandwidth up to 30 kHz. Next one is optical isolation. It should be achieved by optical means in which the patient is electrically connected with near hospital lines nor the ground line. Capacitive isolation. It also uses digital encoding of the input voltage and frequency modulation to send the signal acts across a differential capacitive barrier. Here you have the bandwidth up to 70 kHz. These are the possible questions you will get from this topic. Thank you.